Alright, so this is the design video. It sort of talks about the design choices made for the microEnigma. And the first thing I'm going to do is just going to show off the finished one here. This is a microEnigma with red display and red LEDs. And you can see the letters light up. The thing that it's in is an oak tray. And I'll flip it over so you can see the underside here. It's got a mini USB power jack if you want to power it that way. It also has a, you really see most of that, a 3X by 3 AA battery pack, which I don't have the silver screw in here right now, but these are the rubber pads keep from slipping around on a table. Nice thing about this is that you can kind of see that it gives it sort of a little angle when it's sitting on a table. So you can kind of approach it with like a slanted keyboard and do what you want to do on it, which is kind of cool. So this is what the finished product looks like. But in this video I'm going to talk about the way it's designed and the reason why I designed it the way I did. There's more than a few recreations of Enigma in electronic form, and I think people did a great job with them. I find them very fascinating, but there's a few things that I wanted to do with this project that sort of went into it as a design guideline. You know, one of the things that I really wanted was something handheld. I've always been a person who just likes something I can hold in my hands and use. And so that was sort of one of the goals, was to keep it small. In this case, it's I've got a 10 by 10 centimeter printed circuit board, and the wood tray maybe adds a little under a centimeter on the edges as well. So the another thing that I really like about the Enigma is the layout. I wanted to try to match the layout, and I wanted to use real components. Like in this case, these are all actual real buttons that you can press. Nothing's virtual here. The lamp board is made of LEDs instead of lamps because they're a lot lower power and they last a lot longer, which I really like things that last a long time. There's nothing that annoys me more than buying something only to find that within 3 months or 6 months or a year that it's dead and doesn't work any longer. I find that to be very frustrating. So that's one of the reasons why I build this the way I do. All of the parts are parts I order. The circuit board is a custom circuit board I order, but everything is assembled by hand. So every solder connection on this is done under stereo microscope, where I can see exactly how the solder wicks into the joint, and I know it's a good joint. So that's one of the things that is one of the reasons why it takes me so long to build one of these, is that they're built completely by hand. Every part is placed by hand. Every joint is made by hand. So that's just part of how I build them. Now in this case, I'm using some stainless steel flathead screws just to sort of be period accurate. I tried to style this to look like an Enigma with a light oak tray, with a black circuit board that somewhat matches the powder coated metal of the original machines. I did the sort of layout in the same way as well. You know, I've got an on-off switch where the key switch would be, and I've got four. These are 5 by 7 LED displays, so they actually have an LED like this one inside them, but arranged in a 5 by 7 format. And I've honestly fell in love with these displays because I just love how nostalgic they are. I love how they work. I think they're just fascinating. So actually, the displays are the only component that's not a surface mount component on this whole board. I wanted to use surface mount components because they tend to be flatter, and also you don't have sharp, jaggedy kind of feeling on the underside if you're holding the board on its own. So I'm not sure if I'm going to sell this on its own without the oak tray. To me, the oak tray makes it look so beautiful that you know, I'm not sure if I'm going to sell just the board on its own, but I might do that. So let's go ahead and move over to the open one so I can show off more of the design with it. So this is an open one, and I'm going to try to hold this up so the camera can see it, but I'm going to go ahead and unplug it. So the front we've already seen. This one has a programming header on it because this is a prototype, not the finished product. The finished product has a programming header that's not visible. It's only on the back side. But let's flip this over so we can talk about what sort of design went into this. So first thing I'm going to point out, and you can see I've got some little rubber legs on this one because I didn't like it to slide off the table. I was writing code for it. up here, you can see that I've actually trimmed, the only through-hole part on the board are those displays. And I've trimmed the sharp, pointy edge down so that, and I don't know if you can see this on the camera, I'll try to move this up real closely to it. You end up with a soft little bubble almost. So these are trimmed down so that you end up with a bubble that doesn't catch your finger or isn't sharp on your finger. So the board is built with two basic ICs. You know, my concept here was to try to keep this as simple as possible. I find that simple works best. The more complicated something gets, if it needs to be complicated, that makes sense. But if it can be simple, make it simple. It's more reliable that way. So what I have on here is a single microcontroller. This is an AVR, and I think it's a 325. So just got 32K of flash available to it, and mostly the best thing that it has is the number of pins I need, because the keyboard itself is 26 characters or 26 buttons. So I needed an input for each button. Now there's other ways you can go about putting that in a grid and reducing the number of pins, but then if you try to press more than one at a time, you may get ghosting or other features that aren't really desirable without putting in diodes or more components, which again would make it more complicated. So as it is right now, and the best way to design it was to make each button go to an individual pin on this microcontroller. So this particular model this is a prototype, so the final board actually moves a couple of these parts around, like some of the power parts have been moved up here just because I also added a battery pack and it was closer to put it up here. But the piezo sounder is right here, and this is what makes that click click noise as you type on the keyboard that tries to simulate the sound of an Enigma. The power input, I've got two power inputs on here. I've got a USB power input, and then I've got a battery input. And this particular prototype doesn't have the Schottky diodes that let you plug both in at the same time. So this particular one, you could do one or the other, but not both at the same time. But the finished model that I have has diodes to prevent either from backfeeding each other if the voltage is not the same voltage. So that's kind of a good thing. I always use PTCs to limit current. It's always a safety thing you got to do. You definitely want to have some memory to store it. I'm using an EEPROM here, and this main controller will connect to the EEPROM and remember the machine state. So if you configure your machine, turn it off and throw it in a drawer and pick it back up 20 years later and turn it back on, it should remember exactly where it is. The other thing, I don't know if you don't know much about EEPROMs, is that they are a component that can wear out. So I've actually designed it to round robin use this device so that it can handle like 10 billion keystrokes before it runs out of its design life. Now this is actually a pretty nice EEPROM. It actually has 4 million writes endurance per cell, and it has CRC protection too, which is great. So building on top of that, I've added some more code that does wear leveling that expands that to an even larger value. So the IC up here is what drives the 4 displays at the top, and you can see I've got current limiting resistors all the way across here, and this is a Holtec HT1632C, nice little IC that I basically talk to over SPI from this chip and tell it what to display, and then this one handles all of the multiplexing of these displays, so it's constantly displaying this one, displaying this one, displaying this one, displaying this one. It does it so fast that you can't see that it's actually going from digit to digit. So that's what's really nice about this chip. One of the things about displays is that I really wanted to have a board that did not have more boards bolted to it or other displays bolted to it. A lot of times with a display, you'll end up with sort of a display module that has, you know, the display component along with whatever driver electronics it has on it. But I didn't want this to be more than one board. I really wanted it to be just a single board. So that's why I went with this particular setup. So this all up here is basically indicator display electronics, and then the rest of it down here is sort of the rest of the machine. So these resistors here are current limiting resistors for the LED board, which is done in a multiplexing way as well. There's there's actually 26 LEDs, but it's handled in a 5x6 grid where it moves from one to the next in order, so that and again, it's run so fast you can't see that it's being multiplexed. So trying to think of any other design ideas that I've missed on this. Again, I've tried to make it sort of be stylistic after the Enigma. And you know, one other thing is the power management in this too, which is pretty cool. The original Enigma ran on a battery, and that battery would wear down and wear down and wear down, but they still had to use it. So, you know, a fresh battery would have really bright lights on the lamp board, and then as you were getting more dim and more dim and more dim, they would start getting lesser and lesser bright. So the Enigma here is kind of the same way, in that it supports a voltage anywhere from 2.5 up to 5 volts. So if you feed it 5 volts, they're going to be brighter, and as it wears on down to 2.5 volts, if you're using batteries, as they start to deplete, you can see that it gets dimmer and dimmer and dimmer. That's one of the reasons why I had if you've seen the other video, the option that shows you the battery voltage. You can actually see what that voltage is to see if your batteries are getting low and need to be replaced or not. But that's kind of a cool thing, because it sort of mimics the original machine, where a fresh battery would be bright and a dimmer battery would go down. Instead of most electronics now work on a fixed voltage only. They don't really work on a voltage range, but this is kind of cool because it does. So let's see if there's anything else I am missing on my list of stuff I wanted to cover. I think that's about it. So that's kind of the design method I put into this. I wanted it to be flat as it could be. I wanted it to be handheld, and again, I just love stuff you can do stuff with. So the concept of the Enigma I just find to be very fascinating. Really, the things they were able to accomplish with the limited electronics that they had at the time, and you know, the Enigma being a electromechanical machine, is just really really brilliant, really impressive. So if you have any questions, just shoot me an email. Otherwise, have a great day.